Hey guys, so this is a little bit of help for 14.6, where we're trying to figure out how do we work with more angles than just what's on the circle. You know, we can't find the exact value of every angle very easily, but there are some interesting things that come out of our trig identities for angles that we can create via addition and subtraction of these angles. So for instance, if I took like 45 plus 60, that would be a 105. And if I wanted to know the sine, cosine, and tangent of 105 degrees, there's a way to do that. And what we want to do is figure out a little bit more about how do we find the exact value, not a decimal approximation, but the actual exact value of an angle like 105. And so I'm going to walk you through the formula and make sure you guys understand the formula for using sine and cosine, and we're just going to do 105 for all three of them. But here you see that we have these 6 formulas. We can condense them down to 3 if we want, but it's really just 6 formulas. And it says the sine of an angle plus another angle if we want to combine them to a bigger angle. So for instance, 45 plus 60. So if I saw that I wanted to calculate the sine of 105, one way to do that would be to have 45 plus 60 instead of 105. And that allows me to do the sine of 45, that's my first number, times the cosine of my second number, 60. I'm just following the formula. Now because I used a plus here, I'm going to use a plus here. Notice the cosine is backwards from that, and the tangent has 2 different signs. So I'm going to keep rolling. Then we've got cosine of the first thing, which is 45. And then sine of the second thing, which is 60. Okay. Well, if I look at my unit circle, and I remember that the y is the sine, then the sine of 45 is really root 2 over 2. If you're not sure about that, pause the video, get out your unit circle, and find that value, times the cosine of 60, which is 1/2. Again, check your unit circle. Plus, if I go to the cosine, again, this is the x value at 45, it's root 2 over 2. And the sine at 60, the y value is root 3 over 2. The multiplication on the left is just root 2 times 1, that's root 2, over 2 times 2, which is 4, plus root 2 times root 3, which is root 6, over 2 times 2, which is 4. And since they have the same denominator, it can be written as root 2 plus root 6, which we can't combine because they're different roots, over 4. You can't add 2 different roots. You can multiply them like we did in the root 2 and root 3, but you can't add them. This answer here is the exact value that we would get if we just put the sine of 105 in our calculator. This is the answer we would get. But that's not what you would get in the cosine. Cosine would be slightly different. And it would be different in the order in which we put the sine and cosines in, and the sign of addition or subtraction is reversed. You can see that with cosine of a plus b, we need to put a subtraction in the problem, but it's essentially the same. The last one that's a little bit trickier is the tangent. And the tangent's trickier because, well, for one, we've got to know our tangents, and second, there's a fraction in here. So I'm going to take and do the tangent of 105 over here on the side. If I did the tangent, whoops, get my pen back, tangent of 105, that would equal, now I'm going to use the formula. Now you can't see the formula here, so maybe go back, write it down. I'm going to use it for memory because I can look at this one, and I just know my signs are different. I'm going to think of tangent of 45 plus 60. That's my 105. So I'm going to take the tangent of the first thing, 45. Now I'm going to use a plus here. If you look at the plus formula, it's tangent of A plus tangent of B. So tangent of 60, all divided by 1 minus, and then it's, again, this is minus because I'm looking at the other formula, minus tangent of 45 times tangent of 60. Now, you got to remember when you think about your circle, hopefully you've written down your three tangents, which is root 3 over 3, 1, and root 3. If you think about 30, 45, and 60, those are your three tangents. So the tangent of 45 is 1, plus the tangent of 60 is root 3 over 1 minus the tangent of 45 is 1 times the tangent of 60 is root 3. I can multiply these and just get root 3. So I get 1 plus root 3 over 1 minus root 3. Now today I'm taking that as an acceptable answer. However, if we go back and we remember the rules that we've learned off and on throughout the year, we're not really supposed to leave roots in the bottom. So I'm going to show you how we would simplify that to its official answer. No matter what's on top, we look at the bottom and we multiply by what's called its conjugate. Because we don't want that root down there, the conjugate of 1 minus root 3 is 1 plus root 3. Now coincidentally that is the same thing that's on top, but that's not always true. So don't think that I'm always multiplying by what's on top. It's whatever makes the bottom a whole. When we multiply the bottom, I do that first, I get 1 plus root 3. Negative root 3 times 1 is a minus root 3. And a negative root 3 times a positive root 3 would be negative root 9. And we'll clean all that up in just a minute. On top, I get 1 times 1 is 1. 1 times root 3 is a positive root 3. Root 3 plus times 1 is again a positive root 3. And root 3 times root 3 is a positive root 9. But these are going to clean up quite a bit. For instance, these root 9s are really 3's. And these two guys right here, root 3 minus root 3, should cancel. So on top, I have a 3 and a 1. That would be 4. Plus, I have root 3 plus root 3. That would be 2 root 3. All over 1 minus 3 is negative 2. That's pretty good, but these numbers, we have our little triangle of power here. These divide by 2, and I don't like that I have a negative down here, so I'm going to divide everybody by negative 2. 4 divided by negative 2 is negative 2. 2 divided by negative 2 is negative 1 root 3, and the denominator would now be 1 because we divided by negative 2, and that would be our official answer. We see it's a little bit simpler than the one that's in green, but it does take a little bit more work. It is consistent, though, the amount of work we have to do. So that's good that it's always the same process, but hopefully that helps you with how to do sines and cosines and tangents when the angle is not already on the circle. Good luck.